Hello and welcome to another episode with AWS She Builds Tech Skills North America. I'm one of your hosts today, Brittany Wolfram, and I'm doing the introduction for the first time, so super excited for that. But I am also joined by an awesome host. Tamara, would you like to introduce yourself?
Yes. Hi, everybody. My name is Tamara Gagliardi. I'm also another She Builder, part of the AWS She Builds Tech Skills North America team. Excited to be co-hosting with you today. We have a lot of amazing content to go through. So maybe let's just jump into what we'll be covering today.
Awesome. So we have a really interesting topic today and an awesome customer joining us. So one of the things that we'll be talking about today, if you haven't seen from our episode title, is we will be talking to FMC, which we will refer to their acronym as well as to their full Fresenius Medical Care at the bottom. You can see their website right there. And we're going to be having a different type of episode today where we're going to be talking both the business side and the technical side in one episode. So I'm super excited to get to our topics and hear from the business and then hear from the tech side. We're going to start with the business. And one of the things that, Tamara, I'd be curious what you know about real-time predictive models using machine learning. Any insight into that?
Yes, I know that especially I support healthcare life sciences customers in Southern California, and models are being used across all different industries. Today, we're going to be covering a healthcare life sciences customer, but it can be used for many different modalities within the industry, both for doing predictive analytics, both for personalization of treatments, which is something that we're going to be covering today, looking at also how to use those models. If you think about companies that are maybe developing new treatments, how they can leverage all that data to start understanding different patterns and using those patterns to improve the lives of their patients.
Which I'm super excited about. I know many of us have been touched in our lives by our different family members, close friends that may have been going through different treatments, and they could have really positive outcomes, or they could have treatments that just don't work that great. And personally, one of my close friends just beat breast cancer, which is super exciting. And I know models like this and technology like this is only going to build a bigger and brighter future of tomorrow. So without further ado, let's jump into the business part of the case and hear a little bit about the problem and how it was solved.
Episodes on She Builds North America. Today we have Hanjie from Fresenius Medical Care with us, and she is a director of Computational Statistics and Artificial Intelligence. We are going to talk about their real-time predictive analytics solutions on AWS. Thank you so much for joining us, Hanjie. Before we start, do you mind sharing a little bit about yourself, your background, and your role?
So first, thank you very much for the introduction. My name is Hanjie Zhang. I began my educational journey with a bachelor degree in pharmaceutics in China, where I developed my foundation in healthcare industry. My growing interest in the role of data in healthcare led me to pursue a master in statistics at Columbia University in the United States. So this combination of pharmaceutics and statistics opened doors for me in the healthcare analytics. I started working for Renal Research Institute since graduation.
That's awesome. So could you tell us a little bit about FMC's background and what your group focuses on?
Yes, of course. So Fresenius Medical Care North America is part of the global Fresenius Medical Care, which operates in many countries, offering mainly dialysis services. FMC operates numerous dialysis centers across North America, providing hemodialysis and peritoneal dialysis on patients with kidney failure. Aside from dialysis service, FMC manufactures and distributes dialysis products such as hemodialysis machines and dialyzers. So for my group, I mainly work on two areas. First is clinical trial design, such as the design of large customer randomized clinical trials, work on complicated statistical analysis and epidemiology studies. Second, we also involve in design, developing, and deploying enterprise solutions across artificial intelligence spectrum, such as machine learning and deep learning. For example, the real-time prediction of intraday hypotension, our topic today.
That's amazing. That's really impressive. So when you talked about real-time prediction, can you tell me a little bit about, what was the business problem that, you were trying to solve?
Yes, sure. The real-time IDH prediction we aim to address is of major medical and business concern in our dialysis facilities. IDH is a complication that occurs about 10 to 20% of the hemodialysis treatments. IDH hold a potential severe immediate risk for patients during dialysis and therefore require immediate attention from staff. As such, IDH not only reduces our patient quality of life and is associated with morbidity and mortality, but also result in lower clinical efficiency and effectiveness. While not valid in clinical study yet, it's reasonable to assume that prediction of IDH followed by timely, appropriate preventive measures may lower IDH rate, improve patient outcomes, and may reduce overall burden and staff need.
Wow. So can you give us some of the real-time predictions of IDH during an ongoing hemodialysis session?
Yes, of course. So first is the example of the dialysis session with intradialytic hypotension. So normally a dialysis session lasts between 3 to 4 hours, and we do the blood pressure measurement roughly every 30 minutes. So you can see on the top panel, which is the intradialytic SBP. So, and for this particular treatment, the blood pressure is measured at time 0, 20, 60, 90, and 100 minutes. And here the IDH happened at time 100 because the definition of IDH is SBP below 90, and at time 100 minutes, the blood pressure is 70. So that's indicating the IDH happened. So for our real-time prediction model, we are trying to predict intraday hypertension risk, not too early and also not too late. So you see at the bottom panel, this is the predicted probability. At the first 2 times when the blood pressure is measured, because that is way before the IDH happens, we actually have a very low probability. But within the positive predicted window, which is 15 to 75 minutes before IDH, our model was able to predict a higher probability for IDH at that time point, indicating IDH may happen soon. So, and then next, I will have an example, which is a dialysis session without intradialytic hypotension. And you can see on the top panel, the blood pressure was pretty stable over the treatment. And our model was able to predict a really low probability during the whole treatment.
That's really, really good example. Can you tell me what data was used in the predictive model?
We have trained and validated our IDH prediction model using observational data from about 42,000 hemodialysis sessions in 693 in-center hemodialysis patients. The variables included in the model are demographics, clinical and laboratory data obtained from electronic health record, and dialysis machine data. Dialysis machine data including variables such as systolic blood pressure, diastolic blood pressure, pulse, blood flow rate, dialysis flow rate, and such. Additional variable was also derived from this data, such as the changes in blood pressure, heart rate, and also the blood pressure nadir over the last 10 treatments and the IDH rate over the last 10 treatments.
Wow. How were you able to evaluate the model? What are some of the specific data points that you were looking at as you were evaluating?
So the evaluation of the model performance have 2 levels of analysis. So as I mentioned earlier, the blood pressure was measured multiple times during the treatment. And every time when the blood pressure is measured, and we make a prediction. So the first level of evaluation model performance was based on per blood pressure measurement. So which means each time you have a prediction, you will count it true positive or true negative or sorts of things. So for example, if a treatment with IDH, then you may have multiple true positive, true negatives. And then the second level of the model performance was done based on per session level. So it means although we made multiple predictions during the session, but we only counted one, either true positive, true negative, or such for the whole session. And we do have the definition for this. So if we are able to make a one positive, true positive during the positive predict window, so we will count the treatment is a true positive for the treatment with IDH. And if not, then there will be a false negative. And for the treatment without IDH, anytime we make a wrong prediction, it will be a false positive. And if it's not, then it will be a true negative. So this is our whole idea of the model performance evaluation. For the metrics, we are using the standard metrics in machine learning. So for example, we calculated AUROC, and for our validation cohort, our AUROC is 0.89, which is pretty good. And we also did the calibration plot with equal beam width and with equal number of samples per beam. And you can see from this two calibration plot, it lined pretty well, and it's indicating our model perform very reliably. Besides that, we also have the sensitivity, specificity, and precision calculated considering different IDH probability thresholds. And this was calculated based on the model evaluation we mentioned earlier. Have two levels on the poor blood pressure measurement level, and also we have it calculated on the per session level. So all these numbers are really important for our clinical practice, because this will help us determine what threshold we use, what kind of action we're going to do when we see a higher risk.
Got it, got it. Thank you so much for sharing that. When you talked about it, like, can you tell me, like, how do we interpret the model, such as feature importance?
So for our model, which is the XGBoost, so we use Sharp value to determine what is the top 10 predictors for our model. So as you can see here, the number one predictor is the most recent blood pressure, which makes sense because when you have a low blood pressure, of course, you will have a higher chance to have a much lower blood pressure, which is the blood pressure less than 90. So you can see here, when you have a lower blood pressure, you have a higher risk for IDH. And the same is true for the next two predictors. So when you have a higher IDH rate over the last 10 treatment, or you have a lower nadir SVP of the last 10 treatment, you of course will have a higher chance for IDH. And also, for example, we also have usual filtration rate and fluid removed in this top 10 predictors. So when you have a higher usual filtration rate, you remove more fluid, and you will have a higher chance for IDH. We have discussions with our clinicians, and they really think this top predictors medically sense.
Awesome. Where has this been published? What medical journals, and what's coming next?
Yes, these findings have been published recently in a peer-reviewed top kidney journal, and the link is posted with the video. So the model's high performance in the validation cohort suggests that this tool may potentially assist clinicians in intervening proactively and in real time in patients at risk for IDH. But if to a degree this prediction information facilitates the timely deployment of preventive interventions and translate into low IDH rate and improve patient outcome, this will need prospective interventional studies. We are currently in the preparation for such clinical studies right now. Thank you.
Awesome, awesome. Hanjie, thank you so much for joining us today and sharing so many exciting and inspiring details on real-time predictive analytics solution that you drove in FMC. To our audience, I definitely know you want to learn more on how this solution was developed on the technical side. So in our next episode, we will have Kanti Singh, who is the Director of Data Platform Engineering and Data Management at FMC. She's going to be joining us and share more details on architecture, technology challenges, and so many more details. So thank you so much, and stay tuned for the next episode. Bye, everyone.
Thank you very much.
It was so exciting, Brittany, to see the impact that they're doing with taking care of the patients, using data, and how statistics can help improve the outcome of these different treatments.
Yeah, it's really interesting to dive deeper into the study. So if you get the chance, check out the peer review. It was a great read.
Yeah, and as it was mentioned, Fresenius Medical Care, they're the world-leading provider on kidney care, both for products and services. And if you think about the scale, they operate at about over 2,600 dialysis centers across the US. You think the amount of people that go and get the treatment, that's a large scale of data. Going back to the models, in order to have models that are effective, you need a lot of data to tune those models, to train those models. We saw from the statistic point of view how that works and how you're able to fine tune those models to then create the platform that we're about to jump in to learn the technical piece, which I'm super passionate about. But on this second part, as I was mentioning, we're going to dive deep into the technical aspects of how Fresenius Medical Care was able to create a personalized care platform with near real-time prediction, and how they were able to ingest data from their devices. These are the dialysis machines. We heard what are some of those parameters from looking at the blood pressure, looking at different sensor data that it's coming from the machines themselves, and leveraging this data, putting it through a pipeline to then be able to create personalized treatments, to understand how you can personalize the fluids to then have a better treatment for those patients. We're going to be hearing from Kanti Singh. She'll be joining us in the Q&A. We'll have a Q&A with both of them joining us so that you can ask questions, and we'll cover a little more about, from their perspective, what it is to be women in technology. But I'm super passionate about anything related to data. I think it's driving innovation within all different aspects of healthcare, of life sciences. I did want to share with the audience, before we jump into the video where we'll talk about the different technology and services that were used to create this platform, that we do have a data-driven architecture pattern, reference architecture, which allows you to leverage these references as you're thinking on how you can innovate within your own business. I'm going to share very quickly my window so that we can pop up this information. Let me know if you're seeing it. It might be a little small, but if you click on the link that will be shared shortly, or search for data-driven architecture patterns, you can see different patterns here that will help you get started. The first one talks about building a customer 360 architecture on AWS. You can think about it also as a patient 360 if we're talking about patient data. So it gives you that reference architecture to get started on how can you ingest that data, how does it go through the different cleansing mechanisms to then be able to, if you use machine learning, use it through the models. So we'll share these resources, very useful across different industries. And let me just stop sharing so that we can pop in the video and you can learn more about the architecture and how was it that Fresenius Medical Care was able to achieve this personalized care platform with near real-time prediction.
Episodes on SheBuilds North America. Today we have Kanti Singh from Fresenius Medical Care with us. She's a Director of Data Platform Engineering and Data Management at FMC. And we are going to talk about how they implemented real-time predictive analytics solution on AWS from the technical lens. Thank you so much for joining us. Before we start, can you talk a little bit about yourself, your background, what does your role do, and especially what does your group at FMC do?
Absolutely. And thank you, Jigna and Brittany, for having me. It's a pleasure to be here. I'm Kanti Singh. I'm leading the data engineering, data platform, as well as the data management team in the Data Analytics Center of Excellence here at Fresenius Medical Care. My team and I are primarily responsible for the design, development, delivery of our enterprise global data platform, machine learning, and artificial intelligence platforms at Fresenius Medical Care. Fresenius Medical Care is a premier healthcare company which provides dialysis to more than 2,600 clinics focused around patients living with chronic kidney disease, with extended innovative solutions that is redefining healthcare and setting industry standards.
What would you say a typical day looks like for you?
And that's a great question, Brittany. So as a leader in data analytics platform, it is very demanding, and often it involves mix of technical, managerial, and strategic responsibilities. It involves designing modern data analytics platform, which enables our organization effectively to collect, store, process, share, and analyze the power of data through our 3V worlds of volume, velocity, and variety, gain actionable insights, and make more informed decisions that drive business growth and innovation. Enabling advanced analytics, artificial intelligence, and machine learning techniques in the organization through AI ML algorithms, natural language processing, predictive modeling will enable us to gain deeper insight into patient care, as well as maintain the predictive maintenance, leading improved patient care and cost savings. Having a robust data governance through data management capabilities, which ensure our data quality, standards, and accuracy in terms of the consistency of the data across different sources. So I know I said a lot, but this role involves a lot of different technical and managerial responsibilities.
I can definitely imagine that. I know I'm completely with you. In the previous episode, we had Hanjie with us, and we talked about on the business side, like what was the use case for real-time predictive analysis. But can you walk us through the architecture, because we want to understand a little bit more on the technical side, like what else is used, how does it interact with each other, and stuff like that.
Absolutely. Let me share my screen, and then I'll walk you through the architecture. So on the left-hand side in this architecture, you see there are clinics, which are our dialysis machines, where the patient's treatment are done in the clinics. With the breakthrough of technology, we now have ability to collect machine data through this devices, the IoT devices, and ingest those data sets into our enterprise big data platform. In this architecture, we have leveraged Kafka as our streaming service, which enables us to ingest the machine data every 10 seconds and have those data ingested in the Kinesis data streaming services. Kinesis Kafka connector was leveraged for this integration, which helps us ingesting the data into Kinesis data streams. Kinesis data stream plays a key role in this architecture, which helps with the data ingestion through multiple streaming data sets and enabling the data to be either stored in the AWS S3 Big Data Lake, or also ingest the data into the Kinesis data analytics. You might have noticed Lambda in this architecture, which primarily helps us moving the data from the Kinesis data streams into Kinesis data analytics. Kinesis data analytics is one of the key service in this whole architecture, which helps with building the features, the dynamic features for our intradialytic hypertension model, as well as in integrating the dynamic features with the static features coming from our clinical data set and create that comprehensive feature store for our intradialytic hypertension model. Once the features are created, a Lambda in this architecture is helped to get the inference out of SageMaker by pushing all the feature data set into SageMaker to generate the inference. SageMaker is a highly managed service which helps any data engineers, data scientists to build, train, deploy models seamlessly into the AWS cloud platform. With help of SageMaker, we were able to quickly scale up our intradialytic hypotension model, generate the inference out, and leverage OpenSearch to store the inference results, and then use Kibana to visualize those results in a more seamless fashion. Down below in the architecture, we have our data warehouse, which is our on-prem data center, hosted in our on-prem data center. All the clinical data which are needed for this particular intradialytic hypotension predictive model are ingested from our data warehouse into our S3 Big Data Lake through AWS Glue. AWS Glue also helps us building our static features, which is then integrated with the data analytics, Kinesis data analytics service to get the comprehensive list of features. I'll stop there if there are any further questions.
Kanti, what are some of the technology challenges that you faced?
Well, great question. So our mission to provide superior care for our patients to improve quality of patient every day, every patient every day. The key technology challenge, and which could be also called as an opportunity here, was the ability to enable personalized care during patients' treatment in near real time, which will help our clinicians and the people at the point of care during hemodialysis for any kind of fluid management decisions, which will improve the intradialytic hypotension and also any IDH clinical studies use cases. As you might have already heard from the business demo, that intradialytic hypotension is one of the frequent complications happening during dialysis. It might lead to unconsciousness, hospitalization, even mortality in some cases. So managing this during the patient's treatment will enable us to provide personalized care and also a better treatment, a cost-effective treatment for that patient.
I can imagine, how the data is playing such an important role, and gathering that in a as frequently as possible must be one of the main requirement. Can you talk to us a little bit about were there any SLAs or any specific requirements that you had to meet with this solution?
Absolutely, and that's the key to this solution and the architecture. One of our key goals as part of this architecture was meeting certain SLAs within which we will help the patient's personalized care, right? So we needed to develop a near real-time analytic solution that can collect the machine data every 10 seconds during the patient's treatment, which needs to happen near real time, and then provide that personalized predictions every 30 minutes if a patient is at risk of intradialytic hypertension within the 15 to 75 minutes window during that treatment. And the complexity that needed to be managed in the solution was handling the high volume throughput of the data with low latency time sensitivity solution every 10 seconds. Imagine from where the data is originating to where the data needs to be delivered, and that needs to happen in every 10 seconds. So AWS provided this highly scalable, available solution, which was very cost effective and also helped us scale up and scale down based on our demands.
That's amazing that your SLA and requirements, you're able to do that and able to help people through real time. What are some of the unique features of this architecture?
Well, this is a unique architecture. So the solution allows Fresenius Medical Care to provide personalized care during ongoing treatment. The key to this architecture is the modernized innovation solution, which enables us to do the personalized care through data-driven insights. As I mentioned, the solution has been scalable to perform high throughput, which some of the stats I would like to mention here is the acceptable performance which we have tested for the solution is 6,000 messages per second, which entails to about 60,000 per second concurrent Lambda invocations. So the ability to adapt scaling up and down every component in this architecture with the ease of cost very low wouldn't have been possible without this unique architecture and the partnership with AWS.
That's amazing. Thank you so much for sharing that. I heard that FMC won like a CIO 100 award. Can you talk a little bit about that? That seems to be very exciting.
Yeah, that's a great point. Thank you, Jigna. So this solution was nominated and awarded as CIO 100 Award this year, and it's a great honor for us. It positions our company in enterprise excellence place in the area of innovation. So CIO 100 Award usually celebrates top 100 organizations which primarily is used for IT in the area of innovation, which delivers business value, creating competitive advantages, and also enabling business growth. And this solution fits very well in all those parameters of innovation, enabling growth, as well as creating competitive advantage.
Congrats to FMC on that. That is an amazing accomplishment. On what platforms is this published? Where can we see more?
Great question. So we have published the detailed architecture of this intradialytic hypotension model, the technical architecture, in one of the AWS blogs, and I'll share the link in the chat. It talks about what are the complexities, what are the challenges, and how we came through building the architecture and solving those problems. So I would highly recommend, if somebody is interested in going through the details of the architecture, to go through the blog. It provides more insights. We also have published, this is my architecture episode on this architecture in partnership with AWS, which talks about the tools, technologies, and how we achieved our goal.
That's amazing. I'll make sure that the viewers can see the details on those in the chat. So what comes next? Like after this, what are you thinking as a future?
Well, the future of modern data platform lies in harnessing the power of data, machine learning, and edge computing, along with ensuring the data privacy and security. Right, that's our future. The ability to seamlessly manage data across AWS cloud and any hybrid environment, while also focusing on data governance, will be pivotal to us as next. Additionally, we'll be embracing emerging technologies on and around Gen AI on AWS and other cloud platforms, which will provide us new dimensions to the capability of big data platforms, machine learning, and artificial intelligence.
That's amazing. That's amazing. Thank you so much for joining us and going so deep on the technical details on real-time predictive analytics solution that you built in FMC. I must say that's a really impressive and scalable architecture you have put together, and I'm just amazed how this impacts our lives. So congratulations for that, and thank you so much for driving this. As always, thank you so much everyone for joining us.
Thanks for having me.
Thank you.
Welcome back, everybody. That was an amazing presentation on the behind the scenes of the architecture. We dropped the link of the blog on our comments. I did want to quickly pop up that blog on our screen so that we can see it, and you can reference it through the link as well. As I mentioned, they won an award. This is a scalable solution, and there's so many different components that you can dive deeper into on the blog on how Fresenius Medical Care leverage the different AWS services to build the platform. It goes deeper into the different services, both from the IoT services, so IoT Core, for getting information directly, getting that data directly from the devices. It walks through the solution overview, and it provides the architecture that you saw on today's video, as well as it goes deeper into the data collection, the data ingestion, the data lake storage, and the different components from machine learning and machine learning inference, and how you can leverage that data to derive insights. Within that, I know that there were a couple of comments. We encourage you to continue to post questions, because today, Brittany and I have two very special guests that you've seen on both recordings. We'll be having both of them joining us right now. So welcome to our show at AWS She Builds Tech Skills. It's great to have you. Thanks so much for joining us on the Q&A. I think it's worth another quick introduction for those that are just dropping in now. So maybe Kanti, if you can quickly introduce yourself and then continue on the Q&A session.
Absolutely. Thank you, Tamer. And hi, everyone. I'm Kanti Singh. I'm leading the data engineering, data platform, data management team here at Fresenius Medical Care. My responsibility primarily focuses around the design, development, building end-to-end solution around data engineering, global data platform, machine learning, and artificial intelligence.
Hi, my name is Hanjie Zhang. I'm a director of computational statistics and artificial intelligence. So I lead in two areas. One is computational statistics, so it covers clinical trial design, epidemiology, like model development, and also I will cover the AI perspective. So we cover machine learning, deep learning development solutions for Fresenius.
That's awesome. Thank you for coming back with us. Just want to double check. Y'all can hear me, right? We're good? Perfect.
Yes.
Having some fun Wi-Fi. You know, it's the Midwest and it's wintertime. It's always a little bit of a trip out here. But I do want to highlight this comment again, because this is very impressive. FMC is really doing some impressive work, and you all being at the forefront of it with your teams is amazing. So want to say very impressive, but also thank you for joining us, and thank you for telling us what you're doing, how you're doing it, and taking the time with that. I do want to turn the tables a little bit, because it is AWS She Builds, and kind of dive into my favorite question to ask fellow technologists, fellow women in the world of technology. And Hanjie, I would love to ask you this question first. So what is it like being a woman in leadership in technology?
Thank you for this question. I know, generally speaking, technology leadership is a field where women have been underrepresented. But I think I'm lucky to be in a company with many amazing women leaders. In our company, Fresenius Medical Care, our CEO is a woman. And in DTI, we have Juan, we have Kanti, and many other great women leaders. In where I am, the Renal Research Institute, we also have many women leaders. For me, I think a woman leader in technology, the characteristics we have to have that not really differ that much from men. First and most important, I think it to have a strong technical foundation. You have to get a solid understanding of the core principles and technology in the field. And second, we have to stay current. You know, technology evolving rapidly. Keep learning and stay up to date with the latest trend, programming languages, tools, and industry practices. And third, I would say we have to have developed soft skills. Leadership is not only about technical abilities, it's also including communication, teamwork, problem solving, and conflict resolution skills. I want to say leadership is all about how you carry yourself, inspire and influence those around you, to achieve the common goals. It's really a continuous learning process. Thank you.
Yeah, it is really awesome to hear just others' perspective. And that's why I always like to ask this question. You find out so much. There's technology is one component, leadership's another, being a woman is another. So it's always great to hear that. Kanti, do you have anything to add to your journey as a woman leader in technology?
Thank you, Brittany, and thanks for asking this question. So, as a woman leader in technology, I would characterize my experience is a blend of unique challenges and opportunities. Right? We all have, when we get challenges, we kind of navigate through opportunities. And navigating the landscape requires a multi-faced approach around combining our competence, resilience, and strategic way of handling situations and growing towards it. At times, at least I have encountered there are certain barriers or challenges, but which serves as a catalyst for me to for personal as well as professional growth, reinforcing my commitment towards excellence and also promoting the inclusivity as one of the key skill sets as part of a leader. Central to my leadership approach, I feel cultivation of diverse and inclusive team culture is very critical. By fostering environments where all voices are heard and valued, here at Fresenius Medical Care, we unlock the full spectrum of innovation, driving meaningful progress within our organization and industry. The unique culture and wealth which women brings to this technology world is, at least I feel, is a collaborative communication as well as creative problem solving.
Excellent. Thanks for sharing both your points of view. I did see that there was a question that came up as we were talking about the technology piece that I wanted to pop up and address as our audience continues to add questions and comments. If you have any questions or comments, add them on the comment side and we'll go and address them. And one of them was from the technology piece when we were talking about the models and how those models are created. And one of the questions that came through was if patient information was being used to improve or create those models. And I believe from some of the conversation that we had, patient data was being used to originally create the models. Is that correct?
Yeah. Yes.
Excellent.
Yeah.
Just wanted to make sure we address the audience's questions. And in addition to what Brittany was mentioning on highlighting some of the career journey, what are the aspects that we see really make women resilient in the technology field? I also wanted maybe to hear from your end, Hanjie, and then Kanti as well. What are some of the unique qualities you think women bring to the table in tech roles? I think you already highlighted some of them, but would love to double tap and understand if there are other women out there that are looking to further develop their technical or soft skills. What do you think really would be some of those different qualities that women bring to the table?
Okay, I will start first. The first, thank you for the question. I think I could talk about maybe 3 unique qualities I'm thinking of. The first I would say is empathy. Empathy can lead to a better user-centric designs and solutions in technology. As understanding the end user's need, I think it's very critical to the successful tech products. And second, I would say women have strong communication skills. Women often have strong verbal and written communication skills, which are essential for managing teams, articulating complex ideas. And then third, I would say attention to detail. So a keen eye for detail is critical, in coding, in quality assurance, and project management within the tech roles. So there are many other unique qualities. I would say women certainly bring their perspectives and insights into the tech field. Thank you.
Excellent. And Kanti, on your end?
Yeah, and I think Hanji covered majority of the points. A few things I would like to add is woman has a unique quality of the way they are driving innovation and shaping the technology industry, right? Collaborative communication is the key to that. The aspect of problem solving mindset is another thing which I have been continuously focusing on, and it brings a lot of different areas of growth and contribution to innovation. The unique quality which we focus on is through foster environments where diverse voices thrive, and we are fueling creativity through meaningful processes. The adaptability and resilience which women bring us navigates through grace and pushing boundaries, and which this results in pioneering new solutions, new innovation in the area of technology.
Yeah, it's very impressive. And we always like to ask these questions because it helps our viewers as they're growing in their careers, they're starting in their technical careers. So thank you for doubling down in the qualities that you see and that you find unique that women bring to the table. It's always great. And with that, like we say, these always go by way too quick. But we cannot thank you enough for joining us. And for those that are on and watching, if you have an idea or something that you want us to share on the show, feel free to email us at shebuildsna@amazon.com. And again, Kanti and Hanjie, thank you so much for your time and sharing all of this great knowledge. And with that, that's a wrap for a Tuesday AWS She Builds North America Tech Skills. See you all soon.
Thank you.
Thank you.
Bye.
Thank you.
Very much.
Thanks for
Bye.
having us.